in crisis.
The podcast.
Hello, and welcome to the Knowledge and Crisis podcast. I'm Paulina Sliwa. I am Professor of Moral and Political Philosophy at the University of Vienna.
And I'm Gregor Greslehner, a postdoc also at the University of Vienna.
And we are joined today by Benjamin Schnieder, who's Professor of Theoretical Philosophy at the University of Vienna. Welcome, Benjamin.
Thank you. I'm glad to be here.
So you work, among other things, on explanation. Why don't you tell us about the topic?
Oh, yes, of course. Explanations are what we give when we answer why questions. And why questions, it seems, are really like the cornerstone of intellectual curiosity. And we see that with little children already who start to ask why questions, often annoyingly many.
Everyone who has been near a toddler will relate. What are the kind of answers that one expects from a why question?
Well, answers to why questions should help us understand how certain things come about, what makes them be the case in the world. And often such answers refer to causes, to previous events that somehow generated later events. However, and that is very important for my work, not all why questions aim at causes, that is, events prior to something that is happening. Some why questions focus on the given properties of a thing and put them, so to speak, in an order and declare some properties to be more fundamental than others.
So can you give us an example of a causal explanation and then an example of the kind of explanation that's not causal that you say you're interested in?
Yes, certainly. So a causal explanation, for instance, is what we are after when we ask, why did the Titanic sink? And the answer would be because it hit an iceberg. And now hitting the iceberg is a cause of the sinking, one event preceding another. However, we may also, for instance, ask, why was the Titanic at its time the biggest ship on the ocean? And the answer there would not refer to events prior to the production of the Titanic, at least not typically, but rather to the properties of the Titanic itself. It is the mass, the dimension that made the Titanic the biggest ship in comparison to others.
So I'm curious about whether everything always has an explanation. It seems like some things are mysterious and they're unexplainable. For example, why are we here? That seems like a question that defies explanation. Or do you think it also has an explanation?
There is a big debate about whether every question that asks for an explanation must have an answer. I tend to think that is not the case. I tend to think that there are some brute facts where no further explanation can be given. Maybe that we are here. Maybe that is one of the facts that is brute, even though I personally doubt that.
The small child we imagined at the beginning asking all these why questions probably won't be satisfied with brute facts and will keep asking why. Is it difficult to reach such a ground of explanation that doesn't require any further explanations? We just talked about this one example. Is this more common, that we have to take things as brute facts and stop asking for more explanations?
I think we have to distinguish two things here. One question is, are brute facts common, and is it common that we indeed discover them? And I think that is not common. However, we often have to stop asking why questions and just treat some facts as fundamental, as the basis from which we start, because if we do not start, we cannot do anything. As to the child and the annoying tendency to keep asking why over and over again, the exasperated parent will often stop those chains by saying, just because it is that way. And that indeed is not the claim that we really reached a brute fact. It is more a signal that, as of now, I refuse to answer any more questions. And while that can be out of expiration, as in the case of parents, it is something that in science, scientists must do in order to proceed.
So I have a question about explanation and truth, particularly because you mentioned science. Does an explanation have to be true in order to be a good explanation?
Strictly speaking, if we have an explanation, a genuine explanation, it will be true. In science, we often have to work with assumptions that we know not to be true. They are workable and we can manage to get further insights if we work with them. That is true for assumptions and also for explanations. So in that sense, we can have something that isn't true, but that helps us understand something, even if it doesn't get us the full correct story.
Often we're asking why questions because we want to do something specifically. So in the case of the Titanic, maybe I want to build a bigger ship. And so I need to know, why is the Titanic a bigger ship? So that I know what it takes to build an even bigger one. Are there some why questions where I'm only trying to understand? There are no kind of practical or pragmatic interests involved.
Very, very certainly there are many such why questions that philosophers and scientists ask. They do not ask them for any further purpose apart from understanding that very phenomenon. In mathematics, we have many theorems that can be proven, and we want to prove them in a way that makes us help understand why the theorems hold in certain mathematical systems. Some mathematical theorems have applications in the real world, but most of them do not.
And that also seems like a nice example of why questions that aren't causal. Because when I ask, why is the Pythagorean theorem true, for example, I'm clearly not asking a question about what led to it being true. I'm asking something more general about what is it that makes it true.
Exactly. If you're looking for examples of explanations that are not causal in nature, then the richest source for such examples you will find in areas that do not deal with causal phenomena at all, like in mathematics.
That's also really puzzling, because what makes for a good explanation in such an area? What's the criteria by which we can tell that it is in fact a good explanation?
Yes, if we stay with the example of mathematics, it is often the case that we can prove one and the same mathematical truth or theorem in different ways. And some of those ways will trace the theorem back in the most straightforward way to axioms in the system. And axioms are treated as the fundamental truths in a system. And those proofs then show us why the theorem holds. But often we find proofs that are in many ways roundabout. Sometimes we use insights from one mathematical area when we prove theorems in another. And they will not be explanatory in the sense of really showing why that theory in the other area holds. Nevertheless, they can show us that it holds.
One thing I'm wondering about now is, so you said in a mathematical explanation, very often we're trying to trace the theorem to axioms. And sometimes we might need to use different assumptions or tools from different areas to help us get there. That suggests that the job of an explanation is to break things down, to take something that's complex and kind of trace it to something that's simpler.
Yes, where we do not have causal explanations, it seems that explanations go along with a certain reduction of complexity. We start with more complex facts that we want to understand, and we try to show how simpler facts bring about the more complex facts. A difficult question is to spell out these notions of complexity and simplicity. And there are many debates about various possible understandings of complexity or simplicity that is relevant to whether an explanation is a good one or not.
So sometimes it's about making things simpler. Sometimes an explanation that's non-causal. Maybe it doesn't trace things back to something that's simpler, but it shows you how things hang together. Is that a special kind of explanation? Like an explanation which systematizes things?
That is, in fact, a quite controversial topic. If we are interested in explanations why something is the case, that really show us that one fact holds because of another fact, then it is not clear that in every case in which we understand more systematic relations, we really have an understanding and explanation in that narrow sense. It might be that all that we get is an intellectual gain. We see more of the field, that we are then later able to walk more proficiently, but that we do not really know that this theorem holds because of all these connections.
That connects nicely with the fact that explanations come in different kinds. It sounds like the questions you're interested in, as you said, are explanations why something is the case. So an explanation why this theorem is true. But we might also want an explanation of how things are related. And so maybe these systematizing explanations are explanations how various theorems or claims in mathematics are related with one another, but not explanations why they're true.
Yes, that is exactly what I would think.
Okay, so we talked a little bit about explanation in maths, and in mathematics, obviously many explanations won't be causal. And I'm wondering about other examples of such non-causal explanations. So for example, take the fact that I could have been a ballerina. Is that something that can be explained, that we can ask, why is it true that I could have been a ballerina? Is there an answer to that question? Is there an explanation?
Statements about what could have been the case clearly play an important role, not only in science, but in everyday thinking. We do differentiate between things that could have been the case and things that could not have been the case. And yes, then, indeed, it seems that there should be an explanation of why this would have been a possibility for you, whereas that would not have been. And it seems that explanations of why a certain thing would have been a possibility and another not will refer to your properties and more specifically to certain capacities or powers or potentials that you have. The potentials that you have would have allowed you to become a ballerina. They would not have allowed you, perhaps, to become an astronaut. I mean, I do not know that, but...
Well, I'm wearing glasses. That would disqualify me for a space mission.
Also, for the last question, a bit more practical advice for our listeners who might give or receive a lot of explanations in their everyday life. How can they tell a good from a bad explanation?
Oh my, well, I'd say it's complicated. For sure, you can train yourself to give better explanations, and you can train yourself to better distinguish between good explanations and bad ones. And how do you do that? Well, you must study things. You must study different available proposals for explanations, and you must discuss that with peers who understand the things, and then with training, you become better. And one important factor, as always, is not to think in the beginning that you must know everything. Often we have to refer to experts. Experts can teach us, experts can train us, and then we can become better also in giving explanations.
Thanks so much, Benjamin, for joining us.
Thank you.
Thank you for having me.
This podcast has received funding from the Austrian Science Fund as part of the Knowledge in Crisis project. We're a collaboration of more than 50 philosophers at the University of Graz, the University of Salzburg, the University of Vienna, and are led by Central European University. For more information about our research and details about upcoming public events, visit www.knowledgeincrisis.com. You can also find us on most social media platforms at Knowledge Crisis. Thanks for listening, and stay tuned for our next episode.